studied before ionic and covalent bonding, and we need to compare between ionic and covalent bonding and between ionic and covalent compounds. So the first thing we should look at these bondings. What type of atoms make these bondings? Here in ionic we have metal and non-metal. So if you have NaCl, sodium chloride, this is metal, this is non-metal, so it makes ionic bonding. Here we have non-metal bonds with a non-metal with non-metal. If you look at CO2, this is a gas and this is a gas, non-metal, and this is non-metal. So this is what type of atoms make every compound. In ionic compound, atoms lose and gain electrons. In covalent compounds or covalent bonding, atoms do not gain, do not lose, they only share electrons. Here you will have charges, charges positive and negative. These will not, no charges, no positive and negative charges, because these have ions, these do not have ions. So these, because they have charges, they conduct electricity, but these covalent do not conduct electricity because they don't have ions. So we need to know about this. These, because they have high melting point, they have high boiling point. Those have low melting point, have low boiling point, and these are some of the characteristics and properties of ionic and covalent compounds. You need to understand them. You can read these properties from the book, IGCSE book. You have the properties of ionic compounds and the properties of covalent compound. You need to read and understand why. Also, these dissolve in water, these do not dissolve in water. You can read about these, why these dissolve, why they conduct electricity, why these do not conduct electricity, and so on. Here we're going to have, maybe in exams or anything, you'll just be given like these compounds, and you're not told is it ionic or covalent. You should know, is it going to be ionic or covalent. The first one here, we have magnesium and fluorine, metal, non-metal. So this is going to be ionic. This copper oxide, this copper is metal, this is non-metal, so also ionic is going to be ionic. This carbon and chlorine, non-metal and non-metal, this is going to be covalent. So you should draw sharing. This one will be sharing. This H2O, also non-metal, and non-metal is going to be covalent. This NH3, nitrogen is a gas, hydrogen is a gas, non-metal and non-metal, so it is going to be covalent. This aluminum fluoride, this one, aluminum is metal, fluorine non-metal, so it's going to be ionic. Magnesium iodide, here magnesium is metal, iodine is non-metal, so it's going to be ionic. This is in the exam. If you have compounds like these, you should first determine, is it going to be ionic or covalent? Because if you don't know, is it going to be ionic or covalent, your drawing is not going to be correct. It's going to be cross, and you will get this lovely mark 0 in the exam. So Now let's look at another thing about this. In this chapter we studied isotopes. Isotopes are atoms which have the same number of protons but different numbers of neutrons. So this carbon, if you look at the periodic table, it has the atomic number, this is the atomic number 6 of carbon. So all atoms of carbon have 6 protons, but the mass number can be different here. Look, this atom has 12. The atomic number of this atom is 12. This atom, carbon 13, has 6 protons, but it has 7 neutrons. This atom also has 6 protons, but has 8 neutrons. What you can see, they have the same atomic number, they have the same number of protons, but different numbers of neutrons. This is 6, this is 7, this is 8. So they have the same atomic number, which is 6 atomic number, but they have different mass number, because the mass number is the protons plus the neutrons. So same atomic number but different atomic masses, and we call these numbers according to their atomic mass. So this we call it carbon 12, this we call it carbon 13, this we call it carbon 14. They have these are the mass numbers, but all of them have atomic number 6. This is the atomic number because all of them have the same atomic number. Now the last thing we need to know about this chapter is allotropy. Allotropy is the existence of an element in the same physical state but in different forms. So carbon, here we have carbon, it has different forms. It has diamond, also has graphite, and has what it has coal. We have other allotropies of carbon, but all of them have the same number of everything about them is the same. What is different about them is the structure of the atoms, of the electrons, their electrons, how they are arranged, the arrangement of these electrons. Okay, I'll give you just without drawing here diagram. If you look at carbon here, this is a carbon, and this is carbon, this is diamond, this is diamond, shining like a diamond, and this is graphite, which you has in your pencil. If you look how these atoms are, the electrons are arranged, this diamond is arranged in 3-dimensional shape. It looks like pyramid. That is why the pyramid, if you look at the pyramids, they are so strong. Why? Because they have this shape. So diamond is the hardest substance found in nature. Why? Because its atoms are arranged in this rigid 3-dimensional shape like pyramid. But graphite is not that strong because its atoms are arranged like sheets. Look like you have, this is one sheet and bonded by weak bond with another sheet. Here this is another one, and this is another one. That is why when you write with a pencil, these lines just slip and stay on the paper. And now these are strong bonds, but between these there are weak bonds. Here you have all strong bonds, here you have weak bonds. Now because of these they're arranged in these shapes, so here some electrons are delocalized. They form like a cloud of electrons between these sheets, and these clouds of electrons allow graphite to conduct electricity. So diamond does not conduct electricity, but graphite conducts electricity. Why? Because it has delocalized electrons in these sheets, in these layers of graphite. And that is all what you need to know about this chapter. Until next chapter, ciao.